Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Satellite Communication, and today's lecture topic is Attitude Control from Unit 2 Space Segment. On completion, the students will be able to understand about the attitude control subsystem, define the disturbance torque forces, as well as explain about attitude control methods. Attitude control. The attitude control subsystem should accomplish the following: ensure that the directional antennas point in the proper direction, make the earth sensing instruments to cover the required regions, keep the solar arrays pointed towards the sun. Disturbance torques. The disturbance torques are the forces which can alter the attitude, which includes the external forces which are due to the gravitational fields of the earth and the moon, solar radiation and meteorite impacts, as well as internal forces due to motor bearing friction, movement of satellite elements such as antennas. Horizon detectors. These are involved in the measure of satellites' orientation in space as well as the measure of satellites' tendency to shift. Horizon detectors are infrared sensors which are used to detect the border or edge of the earth in space. By taking the center of the earth as the reference point, 4 such sensors are used, one for each quadrant of the earth. Therefore, if there is any shift in the orientation of a satellite, it will be detected by any one of the sensor. RPY. RPY stands for roll, pitch and yaw axis. Roll axis is perpendicular to yaw and pitch axis. Pitch axis is normal to the orbital plane and yaw axis is directed towards the Earth's center. The 3 axes which define a satellite's attitude are its roll, pitch and yaw axis. All these 3 axes pass through the center of the gravity of the satellite. For an equatorial orbit, movement of the satellite about the roll axis moves the antenna footprint north and south. Movement about the pitch axis moves the footprint east and west, and movement about the yaw axis rotates the antenna footprint. The basic attitude control system comprises of sensors, spacecraft attitude block, correction systems which includes the wheels or jets as well as the processor. Attitude control methods. The 2 main attitude control methods are passive attitude control method as well as active attitude control method. Passive attitude control method uses some mechanisms to stabilize the satellite without using energy supply, and overall stabilizing torque will be applied. Example: spin stabilization as well as gravity gradient stabilization. Active attitude control method. In this method, the correctiveness torques are applied against the disturbance torques and there is no overall stabilizing torque. Examples include momentum wheels method, electromagnetic coils method, mass expulsion devices method. So this is the spin satellite stabilization method coming under the passive attitude control method. Here, the spin stabilization may be achieved with cylindrical satellites. The satellite is constructed so that it is mechanically balanced about one particular axis and is then set spinning around this axis. For geostationary satellites, the spin axis is adjusted to be parallel to the north-south axis of the Earth. Spin rate is typically in the range of 50 to 100 revolutions per minute. Spin is initiated during the launch phase by means of small gas jets. Momentum wheel stabilization, which is an active attitude control method, is comprised of one wheel stabilization system, 2 wheel stabilization system as well as a reaction wheel system. Quiz questions on attitude control. What are the disturbance torque forces altering the attitude? Draw the block diagram for attitude control system. What do you mean by passive attitude control? Thank you.